A student placed a piece of metal P in a test tube containing excess dilute sulfuric acid. The student repeated this with 3 other metals, Q, R, and S. All the pieces of all 4 metals were the same size. The student recorded the observations until each metal had reacted with the acid for 2 minutes. The observations are shown in figure 9. So use this information to put 4 metals in order of reactivity from least to reactive to most reactive. So this is really easy. You're just looking for one where the most reactive would be the most bubbles produced and no metal remains, or very little, or the metal reacts very quickly and disappears. So if you just follow that and you read it carefully, you'll see it's P, R, Q, S. P, bubbles produced very slowly, some metal remained. S, bubbles produced very quickly, no metal remained, and everything else falls in between. Next, complete the diagram below to show how the student could add to the apparatus to measure the volume of gas produced in 2 minutes. So right now this is all they've got. So if you want to measure the volume of gas, you could use the complex upside down inverted measuring cylinder, but a simpler one to draw is you put a sidearm delivery tube and you with a rubber bung there, and then you put your gas syringe here, and what will happen is as gas is produced, it moves the plunger back and you can actually record how much gas is produced, or the volume of gas, every, let's say 10 seconds, every minute, depends what you're trying to, the rate or the unit you want to go for, the interval you want to go for. When iron reacts with copper sulfate solution, solid copper is formed. 2 possible equations for this reaction are copper sulfate plus iron produces copper and iron sulfate, but you can see the numbers are different, so 3 moles here and so on. So it was found that 10 grams of iron powder reacted with excess copper sulfate solution to produce 11.34 grams of copper. Carry out a calculation to decide which equation A or B represents the reaction taking place. So firstly, this is an excess, so we don't have to worry too much about that, and we've got unlimited amount of that. We don't need to worry about iron sulfate because that isn't the desired product. We're not interested in that. All we really need to concentrate are these. So the one which is not unuseful product we ignore, and the one which is in excess, because it says excess copper sulfate, we can ignore. So carry out a calculation to decide which one of these is true for these figures. So we're just looking at these now. It becomes a lot simpler when you're just looking at these. Now you're trying to work out you've got mass here, and you've been given relative atomic mass of these elements. So this is going to be obviously use some sort of equation. And what links in chemistry mass and relative atomic mass? Well, it's going to be a molar equation. So remember, mass divided by atomic mass or relative atomic mass is the number of moles. And that's important because these numbers here represent the number of moles. So over here, these represent the number of moles. So you're trying to find out which is the best fit. This is saying 1 mole reacts with 1 mole. This one's saying 2 moles reacts with 3 moles. So firstly, what we do is we do 10 grams here divided by 56 for the iron. And we do 11.34 grams for the copper divided by 63.5. And you see we get 0.179 and 0.179. You already know the answer then, because what we're saying is we have 1-to-1 ratio. When you have this much, you get this much of the other one. It's the same amount, so it's 1-to-1. So it must be equation A. Just notice how from something very complicated, this looks horrendously complicated, it actually becomes really simple once you cut out the noise and you just really do the only thing you can do with these figures. Acid solutions contain hydrogen ions. Aluminium reacts with dilute hydrochloric acid to form a solution containing aluminium ions, Al3+. Complete the balanced ionic equation for this reaction. I think this is quite a tricky question as well, because there's a few things you need to know to be able to get this. So start off somewhere fairly easy. We know that we've got aluminium reacting with dilute hydrochloric acid to form a solution containing aluminium ions. So you could just do a balanced simple equation of that. We've got aluminium over here reacting with hydrochloric acid to produce aluminium chloride and hydrogen, because when a metal reacts with hydrochloric acid, it will produce a metal salt and hydrogen. But the equation here only wants you to deal with hydrogen and aluminium elements and not chlorine. Now, to understand why, you have to look a bit closer at what's going on. So we're starting off with aluminium, which isn't in an ion form. It's not ionized, it's a block of metal. Now, that's basically reacting with hydrochloric acid. Now, hydrochloric acid is basically hydrogen chloride gas dissolved in water where it's ionized. So hydrochloric acid is basically a solution of hydrogen ions and chlorine ions or chloride ions. And then that produces aluminium chloride in solution, which is aluminium ions and chloride ions, and hydrogen gas. So what we've got here is we've got aluminium atoms becoming aluminium ions, and we've got hydrogen ions becoming hydrogen atoms. So we're getting from not ionized to ionized, and from ionized to not ionized. Chlorine is the only element which starts off as an ion and finishes as an ion. So we ignore chlorine. We call them we call chlorine in this example a spectator ion or spectator element, because what it's doing is just watching from the sidelines. It's not getting involved really. It's not changing. So I've kind of cut forward to this, but you'd have to balance this equation. So you could write these out first and work out how to balance it, and you'll realise you get 2, 6, 2, 3. By all means, pause and have a look at what I did here to work it out. So now you're writing everything down except for chlorine. You write 2 Al, 6 hydrogen ions. Remember ions here because we're not doing chlorine. We write 2 aluminium ions because remember we're ignoring chlorine again. It's a spectator atom. And then 3 hydrogen molecules. So the numbers have come from here, but the only thing that makes this more confusing is the absence of chlorine. The hydrogen ion concentration in a solution is decreased by a factor of 10. State how the pH of this solution changes. Well, if you look at what a pH scale is, it's just a 10-fold increase in either hydrogen ions or hydroxide ions. So, for example, going from neutral and we're going, let's say, to pH 6, more acidic, you have 10 times more acidic particles this way, then 100 times more when you go from 7 to 5, 1,000 times more from 4. But between each step, it's just a 10-fold increase, 10 times more, 10 times more, 10 times more. And this way, it's the same, but it's hydroxide ions, not hydrogen ions. This makes it more alkali, this makes it more acidic. Now, the question is, state how the pH of this solution changes if we decreased by a factor of 10. So the hydrogen ion concentration in solution decreased. So in other words, we're going in this direction. So the pH would get higher. It's important to understand. You can easily trip up and say it gets lower, but no, it gets higher, increases by 1. Next, calculate the mass in grams of a hydrogen atom using the data below. Here you have the relative atomic mass of hydrogen and Avogadro's constant, which is 6.02, or abbreviated to 6.02 times 10 to the 23. So remember, the atomic mass of hydrogen is 1. So that means 1 mole of hydrogen would be 1 grams. Remember, that's how we translate moles. So 1 mole of any element will equal its atomic mass as grams, in grams. So like I said before, 24 grams, or magnesium has an atomic mass of 24, so if you had a mole of magnesium, it would be 24 grams. So hydrogen has a relative atomic mass of 1, so if you have a mole of hydrogen, you have 1 gram. So 1 gram equals 6.02 times 10 to the 23 atoms. Because that's what a mole is. It's a number of atoms. That's a number of atoms. And the number is Avogadro's constant, 6.02 times 10 to the 23. So we know how many atoms there are, but we need to work out the mass of 1 hydrogen atom. So it stands to reason that if 1 gram is basically this many atoms, if we divide that 1 gram by the number of atoms in 1 gram, we'll find out the mass of 1 atom. But how do you divide this number by this number with standard form? Well, firstly, start with this. 1 divided by 6.02 equals 0.1661. Now, when you're dividing powers, you subtract them. So now we're dealing with the powers. But remember, there is no power here, so it's 0. So 0 minus 10 to the 23 equals 10 to the power of minus 23. So what we've got here is the answer would be 0.1661 times 10 to the minus 23. However, standard form has to be written between 1 and 9.9. They absolutely love these at the moment, so make sure you understand how to do this. So I need to move the decimal point here to make this number between 1 and 9.9. Now, by doing this, I'm increasing this number by a power of 10. So to maintain its value, I need to reduce this number by a power of 10. Now, to make this smaller, I need to make it more negative. So a tenfold increase here means a tenfold decrease here. So we write the answer as 1.661 times 10 to the minus 24. Remember, this number got bigger, so this number has to get smaller. And negatives, negative 24 is smaller than negative 23.